All right, we're going to learn to solve quadratic equations by taking square roots. Essentially, what we're going to do is use inverse operations. Just like you've always solved equations in the past, you have added the opposite, or you've multiplied by the reciprocal. Here, what we're going to do is we're going to do the inverse of squaring, which is taking a square root. And we're going to do that at sort of the last step. However, we've got to be mindful of a couple things. One, simplifying radicals is still an important part of what we're going to do today. So we need to know how to simplify radical expressions. Additionally, we're going to have to focus on the fact that there is a principal root to a number and a negative root to a number. And what I mean by that is if I say x squared equals 25, you have to understand that x could be positive 5 or x could be negative 5. Because the square root of 25, we understand is just 5, but there's a positive root and a negative root. If x squared is 25, then x could be positive 5 or negative 5. And we're going to have a fancy symbol that we're going to use, a plus and a minus, that's going to show that we're referring to a principal positive root and a negative root. So let's take a look at this. These are special cases where b equals 0. Given ax squared plus bx plus c equals 0. If we have no b term, if we just have ax squared plus c equals 0, then we can solve by pure algebra, just doing the inverse operations. In this case, we're going to call it solving by square roots. So let's look at this first example. X squared minus 4 equals 0. In order to solve this using basic algebra, we'll add the opposite to get the x squared by itself. All right, we added the opposite. We did the inverse operations. Instead of subtracting 4, we're adding 4 to both sides. That gives us x squared equals positive 4. Now to solve this, we need to take the square root on both sides. And I know most of you in the room have already solved it. You already said x is 2, x is 2. And that's partially true. 2 is one of the solutions, but given the fact that this is an x squared equation, a quadratic equation, we could have 2 answers. And so looking at this, we've got to be mindful that there is a positive square root and a negative square root. This symbol right here, plus or minus radical 4, tells me that we need to take the positive root of 4, the principal root, which we understand is 2, but we also have to consider the negative root. If x squared equals 4, x could just as well be negative 2. Negative 2 squared equals positive 4. Now, one thing I don't have you do is write these as 2 separate things. I don't have you write x equals 2, x equals negative 2. I just say x equals plus or minus 2. X equals positive or negative 2. Okay. Sometimes the examples are this straightforward. You add the constant, you take the square root, you simplify as you can. Other times, if there's an a value that's not equal to 1, there's maybe an extra step involved. Sometimes if the radicals are a bit more troublesome, taking the square root of 4 is not a difficult task, but taking the square root of 32 is going to be a little bit more work for us. And so we've got to be ready for that. So we still have to know how to simplify radicals like we learned in Geometry Chapter 7. And Algebra 1, Chapter 11. So here, same process. Let's add 64 on both sides. Let's divide by 2 on both sides. And then we'll take the square root. Adding 64 on both sides gives us this equation. Dividing both sides by 2 gives us this equation. So these are all equivalent. This is all the same situation. In order to solve for x, we need to take the positive and negative square root of 32. Now to simplify the square root of 32, we have to consider the fact that there are multiple ways to approach it. I, of course, am a fan of being efficient, and so I'm going to pick, instead of 4 times 8, to try to simplify this, I'm going to pick 16 and 2. We know that the square root of 16 is 4. And so this yields our answers: x equals positive 4 radical 2 or negative 4 radical 2. And this is how you solve quadratic equations using square roots or using the algebraic method.